All right. So I just wanted to give you a little help with your worksheet. On this worksheet, I actually took out the questions because I strongly believe that's going to help you to become a better problem solver. So the only instructions I gave you were to use what we have learned in physics class to figure out what you can about each situation. And then it says, number one, it says that t equals 0, if t equals 0 seconds, a car has a speed of 30 meters per second. After 6 seconds, its speed is 15 meters per second. The car's acceleration is constant. Okay, so it'd be nice if you just draw sort of a diagram to show what's going on. So we've got a car that's already moving. Okay, so I'll draw lines to show it's already moving with a velocity of, what is it, 30 meters per second. This is my initial velocity. To make life easier, I'll put my car at a position of 0 meters. I'll make position meters to the right positive. And yeah, there's my diagram of the situation. So the graph would probably be a good next step here. And you wonder which graph should I draw? Well, turns out the velocity graph being in the middle, velocity graph can be used to figure out acceleration because the slope of velocity graph is acceleration. And you can use a velocity graph to find out displacement pretty easily as well. So, and that's change in position. So we tend to do a lot of velocity graphs. They tend to be quite useful. So I'll draw my velocity graph, something like this. Velocity would be in meters per second. Time would be in seconds. And our car starts with a velocity of 30 meters per second. And then at 6 seconds, it's going 15 meters per second. All right, so at 0 seconds, our car is traveling 30 meters per second. And then later, let's say this is 6 seconds, our car is traveling at 15 meters per second. And we're also told that the acceleration is constant. So if that's true, the acceleration is constant, then our velocity graph should have a linear shape. It should look like this. We have a linear velocity time graph, and wonder what we could find out now. There's a couple different directions we could go. You could also draw a acceleration time graph. Acceleration, if velocity is in meters per second, acceleration will be measured in meters per second squared, and time will still be in seconds. And since we have a negative slope on our velocity graph, our acceleration graph will be a straight horizontal line. And I should probably stop my line because I don't know what's happening after 6 seconds. All right? But we do know that this area here has to be our change in velocity, right? So area of acceleration versus time graph is equal to change in velocity symbol for that is triangle T, arrow. Okay. And change in velocity is going to be calculated by taking our final velocity, subtracting from it our initial velocity. In this case, our final velocity looks like it's 15 meters per second minus our beginning velocity was 30 meters per second. So our change in velocity turns out to be a negative value, which is negative 15 meters per second. And so this rectangle here, whatever this value is here, is our acceleration. But now I know that that area of that rectangle is negative 15 meters per second. I know the length of that rectangle is 6 seconds. So I think I can solve for acceleration, because 6 seconds times my acceleration has to be equal to my negative 15 meter per second change in velocity. So my acceleration has to be negative 15 meters per second divided by 6 seconds. Okay? So that means my acceleration is going to be, I don't know, whatever 15 over 6 is. I think that is going to be 2.5. So that's going to be negative 2.5 meter per second in 1 second. And every time you solve for something in physics, you should explain what it means. If you can't explain what something means that you have solved for, then you don't really understand what you have done. And what you've solved for is meaningless. So it doesn't matter to me if you're incorrect in your explanation. We can work on that. Just try to explain every number, every solution you come up with. I think you'll grow a lot in physics if you do that. So for this, you'd say every second. No, I think this is a car. So car, and I'm trying to break it down as simple as I can. Car slows down 2.5 meters per second. So the car is going 2.5 meters per second slower each second. And now you probably want to look up at our velocity graph, and let's see what we can figure out from that. We already figured out our acceleration. That's pretty cool. I'm going to redraw my velocity graph on a new page, and we'll see what we can find out. Our velocity graph looks like this. Velocity time. Okay. And our initial velocity was 30. Our final velocity was 15. And in 6 seconds, we went from 30 down to 15 meters per second. So, question is, how do you find your displacement using the velocity graph in this case? Would you take this area here? Does that sound like a plan? A lot of people do it this way. So there's a problem here. Try to figure out what my error in logic is. So this would be 1/2 15 meters per second, height of that triangle, 6 seconds. And 3 times 15 is going to be 45 meters. So I've seen this mistake quite often. There is a big problem here. Let me show you why there's a problem here. Let's say an object a car we're going 15 meters per second, and in 6 seconds it stopped. Well, in that case, sure, if you slow down from 15 meters per second down to rest, I'd agree with you. Your displacement would be 45 meters. The problem is, in this case, you're going much faster. So even though the height of this triangle here is the same as the triangle on the right, because your initial velocity is much faster than 15 meters per second, you're also going to have to add this rectangle. You could think of it this way too. If you're driving on the freeway, and let's say you slow down from 70 miles per hour to 65 miles per hour because you see a police officer, so you slow down. Or let's say you're driving near a school and you slow down from 20 miles per hour to 15 miles per hour because you know there could be kids nearby. Well, obviously when you're on the freeway, even though you slow down by the same amount, you're going to cover a much greater distance. So the actual speed you're going will affect how far you actually travel, and it should affect your displacement. So just hoping I can help you avoid that mistake that a lot of people make here. So to finish up this problem, the rectangle's area is going to be 15 meters per second times 6 seconds. And let's try to figure that out. 15 times 2 is 30. So 15 times 4 is 60. So 15 times 6 should be 90. Let me just check that. 15 times 6. Yeah, cool. All right. So I'm talking about 90 meters. And it would make sense then to figure out our total displacement would therefore be 135 meters. That's our total displacement. Since in our first diagram we have our object starting from 0 position, this would also be our final position. So, and this would also be the distance we've traveled. And that is while slowing down. So I can write that here, while slowing down. So I'm pretty sure that's about it. If we did have questions on this problem, we would probably ask you what's the acceleration of the car while it's slowing down, and what's the total distance it travels while slowing down. But you don't really need the question. You'll actually learn more, and it'll be more like real life if we just give you situations and you try to figure out what you can. Also should be more fun, more interesting, and you should get a lot better throughout the year at being able to solve real-life problems. Anyway, hope you enjoyed this, and I hope it helps you get on the right track with the worksheet. Have a good day.